Hello, it's Advent of Code time, so I'm going to spend tonight streaming writing Advent of code, I guess. I, yeah, I'm going to take a break from writing Showtime and doing useful practical Haskell, and do kind of fun puzzly Haskell instead for the next couple of weeks. I haven't done many of the Advent of Codes this year. I did days 1 and 2. I started 3, but didn't get very far, and then just threw it away. But today I'm going to pick up day 7 because that's the most recent day that's been published at this point. I had a quick look at it before I came on air, so it looks like it should be appropriate to do. I don't know how far we'll get, but it should at least be kind of interesting. So let's get cracking, I guess. So here we have a very long description, and it's all very lovely and wordy, but essentially you have a deck of cards. So ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. And then you get a hand containing 5 cards, and then there's some rules, poker-like rules, without any suits. So they're just cards without suits, but similar rules. So you get 5 of a kind, 4 of a kind, full house, 3 of a kind, and so on. And then you have to rank these in terms of the best hand. So we have 2 things which are equal. I think in an example, 2 4 of a kind. No, in this example, you got 2 4 of a kinds. You basically start from here. Because they're both 4 of a kind, you start from the first number and you pick the highest. So in this case, the one starting with 3 wins. And you keep going if it's the same, then you look at the next number and then the next number and so on. 1 second, I'm gonna sneeze. I'm gonna sneeze, not sure. No, we're good. Okay, so yeah, so the idea is you take these different hands, you work out, or you rank them basically, but you go from the strongest hand to the weakest hand. And then just because it's Advent of Code, there's some multiplier as well. So your weakest hand gets multiplied by 1. So these are the bets you're placing on as well. So you rank them top to bottom. You take the bet amount, the bid amount, whatever it is, and you multiply it by its rank. So the lowest one gets multiplied by 1. It's this in this example, it's this number multiplied by 1. And then you take the second highest and you multiply by 2, and so on. Then you sum up those multiplied numbers. Okay, so that's the challenge for this week. Just going to grab this input text, and I'm going to go and find VS Code. Okay, I have this kind of harness for writing Advent of Code this year, so I'm just going to plug it into here. Little bit of, oops, wrong button. A little bit of, no, very wrong button. A little bit of boilerplate setup. I'm going to create a file for day 3. Grab the line. Okay, and we're going to export 2 functions from this. One is part 1, then there's part 2. So part 1 and part 2 actually. We're going to go from string to string. Part 1, for now I'll just say part 1, pending. And then part 2 also goes from string to string, and it's going to say part 2 pending. Okay, it's done that. I'm going to go to the Cabal file. I'm going to here export the module, expose the module, save that. Go back here, make sure I've saved it. I have not saved it, so I'm going to save that file. It's got stuck in input, that happens sometimes. Okay, when that's restarted, I'll restart it now. I have a test and a main program. So the main program, just save that. Restart HLS, maybe. I should be able to say run day 3, and then it'll be day 3 dot part 1 and day 3 dot part 2, and basically all it does is it prints out day 1 and runs part 1, and then it prints out day, this is not day 3, this is day 7, so I'll go and fix that file, but it should print out day 7, this string, part 1, and then it'll run the part 1 and print out the output, and here it'll be day 7 as well. I'm just going to fix this before I forget, so that's day 7, rename this to be day 7, and rename this to be day 7, save that, go back to main, save that, restart LSP because it's got unhappy again. Oh, maybe it's happy. No, it's not happy. Restart LSP. I basically want to give me an error here, and then I can say to it import qualified day 7. Okay, that'll work. That's so I can say compile run, it'll compile it. Oh, and it hasn't got any input for day 7, so I need to do that as well. So under input, I'm creating a couple of files. So we'll have day 7 here. I'm just going to, oops, not put that in because that's not the right thing. I'm going to copy this and drop it into there. So the idea is I'll replace in a second with the real input for day 7, but this should be enough to get me started. I'm going to go back to here and rerun it. Okay, so these answers for day 1 and 2, but the ones we're interested in are at the end, so day 7, part 1 and part 2. And it's just these functions, part 1 pending and part 2 pending. Okay, the other thing I'm going to do quickly is I should be able to save this as day 7 part 1 sample, and this will get used in the tests. So in the tests I have something kind of similar, but what I can do is say for day, oops, I need to put day 7 in here, but run day 7 part 1. To do that we run the module day 7 part 1. Let me just put that day in place. And then the answer for this should be 6440. That. Okay, and then from here I should be able to import qualified day 7. Okay, and then if I go back to my shell and I run compile test, it'll recompile it, but essentially it's just checking that I get the right answer when you put the test data into the day 7 module. And here it expected 6440, but I got part 1 pending because I haven't done it yet. Okay, day 7. Right, so this input we want to parse into a hand of cards. So we'll take a single line. Here we want to parse this into hand of cards, space, and then the bid amount. So each hand, I guess, will consist of the actual cards and then the bid amount. And we want to work out what rank or what type it is. So we need to look and say, is it 5 of a kind? Is it 4 of a kind? And these will need to be comparable as well. So I guess we'll have a type. So just to start sketching this out, what am I doing with type? So data, which I'm going to put at the bottom of the file. So part 1 and part 2 live together. But anyway, data cards, card, going to be card, is going to be, and then we want to go from low to high here, I think. So we can say it's going to be 2 or 3 or 4, I'll get there eventually, or 5 or 6 or 7 or 8 or 9 or 10 or jack. Very interesting this, isn't it? Or queen or king or ace. I just ace. Okay, here we go. Deriving stock, and we want to be able to show it. We want to be able to compare and see they're the same. And I'm going to put ORed on there as well, so we can say 2 is greater than 3. Okay, I don't know if I need to model this as a data type, but I'm going to do it because it feels right. Okay, the other thing we have is they called it type. I can't call it type because that's already a. Well, it gets confusing if you call types type, I think. Because type is a type already. So I can call it maybe hand type. Let's do that. So hand type is going to be 4 of a kind. Yeah, hand underscore type. So the Haskell equivalent hand underscore type would be hand type with capital letters. Can be 4 of a kind. Is it 4 of a kind, 3 of a kind, 5 of a kind? Wow, it's really good. But I want to do these the other way around because I want to go from low to high. So it can be high card. What have we got? High card, 1 pair, 2 pair, 3 of a kind. Three of a kind, and then is it full house? 3 of a kind, full house, 4 of a kind. Full house, 4 of a kind, or 5 of a kind. And here again we will derive stock, show, EQ, and ORed. Okay, so we have that, and then we're going to have a hand. And this is going to be a record, I think. So we're going to have cards, which I'm going to make, just make it a list of card, I think. It is 5 cards, but I'm not sure it's worth encapsulating the number of cards. Let's see, I'll probably do that later. We have cards, we have a bid, which is just going to be an int. And we have a hand type, which is going to be a hand type. Okay, and again, deriving stock, show, EQ, not ORed. We're going to have to implement ORed ourselves. Okay, lots of stuff. So to parse a single hand, I'm going to go from a string to hand. So parse hand, let me just move it to the center of the screen. So parse hand, typed it wrong. What have we got here? We got 2 things. So we can split it on this space, and then we get the cards and the bid. So we could say something like let cards and bid, and this is going to be l.span, and then you can say something like char that is space of s in let me ignore the hand for a second. I'm just going to grab the bid, and the hand type I'm going to put as high card for a second. Okay, let's pull an L. So data.list and data.char, not a character, it's character. Okay, so now I'm just going to check I pull out the bids correctly. Got to start somewhere, right? So here it's going to be show of map parse hand of lines. Okay, so you get a list of hands back, and each hand should have the bid set correctly. That's what I'm thinking. Oh, no parse. Okay, so something is wrong with my number. So let me just check what span does. I think it might be because I have an extra space. Well, REPL. Why not? Import data.char, import data.list. S is going to be the first line here, so this thing. Nope, I cannot select the line. So that, and then I wanted to say span of is space S. Ooh. That's not what I expected to get back. Okay. Span goes from A to bool, list of A, so list of A's in this case is a list of characters, is space, and you should get back the things up to the point it first matches. So I expect to get this back as the first element, and then this back as the second, although maybe you get space as well. But for some reason that's not matching. Let me try just a more explicit is space. Still wrong. Okay, what happens if I say it's equal to 3, not 3, let's say T. It's not working either. Maybe it's not span that I want. Oh, maybe span carries on while it matches and stops. Okay, so this would be span not equal to T. That's it, okay. So it'd be span not is space. Get me back the answer, but then I do have this extra space at the beginning. So we need to take the tail of the second element. Okay, is there an equivalent of span maybe called break that does the not of the thing that span would do? Yeah, maybe. So we say break rather than span. Okay, that's the one I wanted. Okay. So it's not l.span, it's going to be l.break. And here we want to read the tail or bid. Okay. Let's just run it again, see what happens. Okay, we now have the bids, and the bids look roughly right. Remember 765. Okay, next is the hand itself. So I want to turn this into a list of cards. Okay, couple of ways you could do this. I wonder if actually because we've got overloaded strings, so I could implement the isString type class so that if you interpret like T in the context of it being a card, it would turn it into a 10. But I don't have a list of strings, I have a list of characters. So it's probably not the best way to do it. So I'm just going to have a very boring parse card, and that's going to go from a character to card. Parse card. Well, wonder if there's anything in enum that would help me here. Probably not. I'm going to write this out because it's not that difficult to do. So 2 is 2. Oops. 3 is 3. 4 is 4. In the back of my mind, I'm thinking I could turn all of my cards into a list, and then I could turn this into an integer, and then use that as an index into the list. And then I don't have to worry about 10 10 Jack, Queen, King, Ace. Okay. Google, from enum, can I get to a list? To enum, from enum. Oh, from convert from an int to enum. So I can give it an int. Okay, let's see if we can do that. It's going to be longer to type, but more interesting, which is, I guess, kind of the point of this rather than actually solving the things. So I'll do the special cases first. So ace, oops. Ace is ace. Oh, not that. Not that either. K is king. Q is queen. I'm going to assume the list is correct. So when we get down to things that are not in this list, I'm going to assume it is a number, and then just let it crash if it's not. So this is Jack. First card of T is 10. Otherwise, I want to say data.enum, so I'll call it e.toenum. To enum, and then we're going to read I. We're going to read. Okay, this is now a character into an int. Is there a thing for character to an int? Probably going to be data char, but let's have a look. So it's we have a character, we want an int, and we don't want ord. Digit to int. Okay. This is going to be digit to int, and that's on char. Okay, that might work. Let's find out. So the actual cards, we will have map parse card of cards. So we'll bring that back into scope. Let's see if that even compiles. Okay, first hand, 5, 4, 10, 5 king. Okay, this is completely wrong. The 10 and the king were right, but the 5 and the 4 should have been 3 and 2. And the next one is 10, 7, 7, Jack 7. 10 is correct, 7, 7 is wrong, Jack and 7. Okay, it's just I've got my order wrong. I would have, oh, hang on, 2 is actually 0. Right. So we're out by 2 each time. That makes some sense, I guess. So 3, 2, 10, 3 king, 3, 2, 10, 3 king, and then what have we got? 10, 5, 5, Jack 5, 10, 5, 5, Jack 5. Okay, cool. So now our hands. Next thing is to work out what type of hand it is. based on these rules, 5 of a kind, 4 of a kind, and so on. I'm doing 25 minutes. Not sure how far we'll get with this, but we keep going. Okay, so parse hand kind. I just call it hand kind because it's not a parsing thing at this point. Okay, it's going to take a list of string. No, it's going to take a list of cards, sorry. And it's going to return a hand kind. Okay, let's do the easy one. So 5 of a kind, what I think that means is that every card in there is the same. So I think if I say l.nub, that removes duplicates. So if you move all those duplicates from the cards, and you only have one card left, so that, if that's equal to 1, then we have 5 of a kind. Fortunately, I don't have that in my test input. But we do some 3 of a kinds, so we can keep going. Hand kind, it was hand type. Sorry. Multiple declarations of hand type. Where's the other one? Here. It's inside a record, it should be okay. So I want to say, as well as overloaded dot record, it's something like duplicate something. Haskell duplicate record fields, although they're not record fields, so maybe I can't do that. Okay, so it's not that, I imagine. I'll just rename it so it's something like we call it calculate hand type. Right. So they're all the same. We get 5 of a kind. I think if you have 4 of a kind, then this will be 2. So there'll be 4 things which are the same, and then 1 thing which is not. Those are the easy ones. Okay, now I want to... Oh, actually, is there anything that splits it into its elements? Full house 2. Full house will have... yes, you're right. Full house will have that. Damn it. Okay, so much being clever. So only 5 of a kind would help. But let's see if we have something in data.list which will take. We're going to take a list of A's. We're going to turn it into a list of A's subsequences. Is it that? Maybe not. No, it's not permutations either. All initial segments? No. I kind of want it to sort the list and then pull out the groupings. But I can't see something in base that does that. It's only these ones. Okay. It'll be somewhere near break inside here if there's anything useful. So splitter is not what I want because I don't know what I'm splitting on. Not span, not drop while, not take while, not drop, not take, not cycle, not replicate, repeat, because I don't want to create lists. No, I don't think we have anything. Okay. So let's say, given a list of cards, I want to sort it and then split where the next card, the card you're looking at, is not equal to the previous card. Actually, it's probably easier to look ahead. So we want to say like partition. And given a list of cards, I could probably make this more generic, but I could say given a list of cards, return a list of cards. So given some cards, first thing I'm going to do is sort them. Okay, so we now have a sorted list of cards. And then I'm going to say go on that. Where go, again, is from list of cards to list of cards. Yeah, maybe. Okay. Let's look at the last case. So if you read the last thing off, okay, let's very base case, right? If you're an empty list, you get nothing back. If you only have X, then you get a list containing X on its own. If you have X and it's another tricky case. So if you have X and Y, not tricky case, so simple case, and X is equal to Y, then you have a list containing X and Y. Otherwise, you have a list containing X and a list containing Y. My garden there. Reformat it. Okay. Can I put them online? Yes, I can. Okay. Now, if you have more than that, so you have an X, Y, and I guess C's, Z's in UK speak. Oh, we don't know what Z's is yet. I was going to say if these are equal, then we can group them together, but you don't know what's inside here. God damn it. Is that okay? It's not okay. I might need an extra thing to tell me what I'm currently looking at. So here, if I have the current card as well, I'm just going to rewrite this from scratch because I think it'll change the way I think about it. Okay. So, base case. It's always going to be this. Otherwise, if you have X and some other X's, what we're going to do, oh, and something to compare it to. If we are the same as the previous, doesn't really work because I have the same problem here. The problem is looking ahead, not looking back or looking at the current position. Problem is you don't know what to join it onto. Maybe I'm using the wrong data structure here. Maybe we want to not sort the cards. Maybe I want to put them into some kind of tree. And then if we've already seen it, then we just increment that counter. So what we end up with, if we put it into tree, you take the first card, you put it in, it becomes the only node. Take the second card, if it's the same, it doesn't have to be a tree, it can be it could be a map. I probably really want a map. Okay. So I can say something like type partitioned cards is a map of card. So card we've seen to list of card. Something like that. Then we should be able to import. Oh, can we import to the map? Don't tell me I don't have. Can I load it? Hidden containers 068. And this is in library, so it all depends on containers. Oops, not that one. What was it? 0.6.8, is that right? 068, cool. Okay, and I should be able to import that. Okay, so now for every single card, what I want to do is take partition cards oops, I hope that might go, sorry, you won't see it from outside. So it's just, I'm going to say go, and then I can say m.empty. Where go goes from partitioned cards. And it takes a list of card, and it's going to return you a new list of partition cards. And goes undefined for a second. So can I import this? Import data map as M. Not that. Oh, sorry, yes, this gives me back partition cards, and I want to get the keys from that. Is that right? m.keys of that. No. Could match single card with list of card. Confused here. What's m.keys give me back? It's values I want, not keys. It's not called values, it's called elms. Okay. Slightly better, so I can then do that and then add reduce it, can I? Yeah, I don't need the brackets. Okay, so what do we do here? So we have our list of our partition cards, and we have some cards to put in there. So if we have an empty list, then we just return everything we gathered so far. If we have X and something else, then we want to say m.modify or insert. No, m.insert. Oh, this. I don't think it's insert. I want, is it adjust? One of them will allow me to provide a default. So the type I'm looking for is given some map of key to B and a function which goes from V to B and the key to look up. It should give me back a new map. That gonna work? Yeah, so that's adjust, that's a normal adjust, but what I actually want is some default value. Okay, try swapping these around in case the ordering matters. No. Okay, so adjust is the closest I can get. Update that with the result of that. When the key is not a member, the original map is returned. It's not quite right. Is it update? Nope, that deletes it. Delete update. I kind of want to like an update or insert. Alter can be used to insert, delete, or update. That's this looks better. Okay, so we look it up by the key. We get a maybe A. We return a maybe A. Right. Alter. What are the arguments takes? Alter takes our function and then the key and then the map. So our function and the key, which in this case is X, and the map, which is PC. Okay, so the function is going to take, I'm just going to call this insert or add. Oh, we're already in where. Okay, so insert or add, it's going to take maybe a list of card, and it's going to return maybe a list of card, although it's actually going to be always just. So insert or add with A equals B. No. So this X, I'm going to rename it C. I'm looking up by C. So I'm going to look up in my map and say, do you already have a key in here, which is this card? And if it does, then this function will get called with just that list of cards. If it doesn't have it, it'll be called with nothing. So I think here I can say just some cards, and what we want to return here is just, and then our new card, doesn't really matter what it is. We don't have access to it. We want to make it slightly longer. We want to increase it by 1. I'm just going to pass it in because why not? We will need it in a second. We don't need it for the case where we find stuff because you could look it up, but we need it for the case where you cannot look it up already because you don't know what it is. So it's C added onto C's, and then insert or add C of nothing. So this is the case where it's not already in the list. That's going to be just C as a list. Okay, this has altered our map. So we can say new PC is equal to that in, and then we just go again. Okay. So back to calculate hand type. So first thing we're going to do is we're going to partition our hand, partition our cards, and now we have our list of cards. What do we do with that? We then want to say if you have a single array and its length is its length is 5, then you have 5 of a kind. That should be an easy case, right? So Go is going to go from a list of cards to hand type, and then Go where we have, let me write it as guards. I think that's the way I wanted to go. Although if I'm writing as guards, I could just write as a case statement. Case that of, okay, if we have, no, sorry, I don't want this case statement. There was a reason I was writing as guards. Because then I can do length comparisons, not just pattern matching. Okay, so where are we? So we have a list of cards, and then we could say the length of C's is 1, so they all fit into one list, and that's going to be 5 of a kind. When the length is 2, and the length, and one of them is 4 cards long. We don't know if it's going to be first or second. Okay, and any, is it any? Can't remember if it's any I want. So given some list, you can say L, sorry, the length of L is 4. And this is going to be 4 of a kind. I don't know how much I trust my logic here. I've typoed there, that's a problem. That's a problem. Oh, L dot any of C's. Okay, do that. And do that. Don't know why it's broken. I'll look at it in a second. Okay, let's keep writing its cases. So if the length of C's is 2, if it's not 4 and 1, then it must be 3 and 2. So this would then be full house. Okay, if the length, I'll put my otherwise case in so it stops complaining all the time. That's going to be high card. What else can we have? So we got 5 of a kind, 4 of a kind, full house. 3 of a kind. So we're going to say if the length, no, if L dot any, and then we say length L is equal to 3. So it's not a full house, but you have got 3 cards, then that's going to be 3 of a kind. I'll be amazed if this works. Otherwise, if you have 3 things in the partitioned list at this point, it can't be 1 pair, because that would have 4 things in the list. So if the length of C's is equal to 3, then we're going to have 2 pair. If the length of C's is equal to 4, then we have 1 pair. That should cover everything. Okay. Let's reduce this, but what's its problem here? It couldn't match type list of cards to hand type with actual type list of hands. So that. So we can say go dot partition, then we just get rid of cards. Okay, I'm skeptical, but let's give it a go. So we can calculate the hand type. So in here, rather than just saying hand high card, we can say calculate hand type of our cards. Calculate. Oh, we need this. Okay, so I need another name. So we need a name for the list of characters. Is there anything in here? 5 cards, so maybe call it card labels. And we'll say cards is equal to map parse card on labels. And this becomes cards. There. And this becomes cards. Okay. And let's give it a go and see what it says. Okay, so the first one says 1 pair. First one is one pair. The second one, no, the second one is three of a kind. Three of a kind, okay. Next one is two pairs, so king, king, 6, 7, 7, yep. And the next one should be two pair as well. Okay. And the last one should be three of a kind. Well, I'm surprised that worked. Okay, cool. So, all good stuff. So the next thing I want to do is rank these in order. Okay, so I need to put some kind of orderable on my hand type. Is that right? No, hand type is really orderable, sorry. I need to put an orderable onto my hand itself, and then we can sort them. I would not like to debug this code. Okay. Instance ord of hand where, and tell me what I'm missing, compare or less than or equal to. Which one do I want to do? Compare. I can do compare. A and B, they're both hands. So we want to say can we do it like this? I'm going to say if a.hand type is equal to b.hand type, we have a problem here. I don't know what we do with that. For now, let's just say error. Oh no. Otherwise, no, it won't work. Otherwise, we can just, if they're not equal, we can just compare them. Compare a.hand type with b.hand type. Okay, this case, if the hand types are equal, then we need to start comparing the cards. Compare cards, compare hand, compare cards of A and B. In fact, A.cards, B.cards. Can I just use a straightforward compare on that? No, because it won't do them element by element, I don't think. Have a quick look. 12 REPL. So we can say A is it's going to be a list of cards, right? So we could say something like, let's find an example they use. So king, king, 6, 7, 7. King, king, 6, 7, 7. Ooh. Import day 7. Oh, I can't import day 7. I can, but I don't have access to kings and stuff because they're not exported. Oh, that's annoying. Let me try with ints. Okay, so we can say A is equal to, have they got one that's just integers? No, they don't. So it's going to be 13, 13, 6, 7, and then 7. And B was King 10, Jack, Jack. So King 10, Jack, Jack, and I forgot what the last one was, and then 10 again. 10. So we say compare A and B. We expect A to be greater than B. Aha, I cannot do that. Reset. So now this is a list of int. And this is a list of int. And then we'll try and compare them again. Okay, A is greater than B. That's good. And B is less than, oops, sorry, B is less than A. And then the other example they had is 10, 5, 5, Jack 5. I'm going to assume it works. So if they're equal, then we compare the cards. If they're not equal, we compare the hands. I'm going to compare hands first, then cards, just because it makes more sense. Okay, so now in theory we can compare, oh, I've lost my place, we can compare hands. So we should be able to sort the hands, that's what I'm thinking. So we go to here, we go show dot sort dot L dot sort, because I've made it orderable. And then let's just run it and see if it gets them in the right order. So 3, 2, 10, 3, king is the first one we have. 3, 2, 10, 3, king is the first one. And then we expect it to be king 10, Jack, Jack 10. King 10, Jack, Jack 10, that's good. The second one, and the third one is king, king 6, 7, 7. Okay, cool, we're looking good. So we now know the rank. Okay. So just for fun, we can zip it with some numbers. And it should default okay, I think. I was comparing because it doesn't know what type it is. No, it doesn't know what type it is. Okay. Zip it with that. So we should get 1 and then the first thing. And then what we should be able to do is for each of these things, so we will have a pair going from the rank and the hand, and we want to say rank multiplied by hand dot bid. Okay, and what's going to just said? You zip with, okay. Okay, so you get rank and a hand, we multiply the rank by the bid, and then that actually gives back a list of numbers. Seven, 6, 5. 220 times 2, 28 times 3, whatever. Okay, and then we just sum them. Six, 4, 4, 0. 6, 4, 4, 0. So if I run the test, it should pass now. Okay, good. So if we go to the day 7 input, and down here we'll get our puzzle input. Whoops, I should delete this first. Just drop them in there, and then we can get rid of this. Okay, and go back to here and say compile run, and it gives us this big number. That's a very big number. I'm a bit scared it looks wrong to me, but you never know. Drop in there, submit. Yay, I got 1 gold star. Cool. Okay, we've just gone past 10 o'clock here, so just over the hour. So I'm going to call it a day and not continue to part 2. Yeah, I'll oh, hang on. Now we have jokers. Oh, no, I'm not going to do it now. It'll just take too long. I'll come back to it later. But yeah, cool. So there's my solution for part 1 of day 7. So maybe a bit of fun with enums and orderings. And this just scares me. Horrible piece of code. And partitioning is not beautiful, but it kind of works. Cool. All right. Thanks for watching along. And hopefully see you next week when we'll do some other random Advent of Code day. Cool. See you then. Goodbye.